Okay, so similar to the previous video, we are going to be finding the general solution to this system. And the first step is to find the eigenvalues and eigenvectors, and that will sort of guide us for what we need to do on the following steps. So for the eigenvalues, remember we said the determinant of m minus lambda I equal to 0. So we want to look at the determinant of 2 minus lambda minus 5, 1, minus 2 minus lambda, and set that equal to 0. This becomes lambda minus 2, lambda plus 2, plus 5. So now let's think through what's going to happen. So the part in parentheses there is just going to be lambda squared minus 4. And then when we add the 5, this is going to be lambda squared plus 5. Okay, so lambda squared plus 1. And so now we see that if we set this equal to 0, the eigenvalues are going to be plus and minus I. So one eigenvalue will be positive I, one eigenvalue will be negative I. Okay, so let's just pause for a moment and let's say that we have found the eigenvalue V. It is associated to the eigenvalue I, so in other words, mV is equal to I times V. When we're dealing with complex eigenvectors and complex eigenvalues, the general form for the solution is going to be C1 times the real part of e to the lambda t v plus C2 times the imaginary part of e to the lambda t v. Okay, and so here lambda is going to be I. So here I'm saying lambda is equal to I. We could do the same thing with lambda equals minus I, and we'd have a different eigenvector. Okay, but we're going to do things. We're going to pick lambda equals I as being the eigenvalue. Okay, so we need to look at the product e to the lambda t times v and split this into its real and imaginary parts. And so first we're going to have to find the eigenvector associated to I. I just wanted to point you forward to what we're going to be doing. Okay, so for the eigenvector, we're going to solve the equation 2 minus I minus 5, 1 minus 2 minus I times xy is equal to 0, 0. And it might be a little more difficult to realize when we're dealing with complex numbers, but actually the bottom line of this equation, or rather the top line of this equation, is going to be equal to 2 minus I times the bottom equation. So the top equation is 2 minus ix minus 5y is equal to 0, and the bottom equation is x minus 2 plus I y is equal to 0. So the top equation is 2 minus I times the bottom equation. Anyways, the bottom equation tells us that x is equal to 2 plus I times y. So any vector where the top entry is 2 plus I times the bottom entry is an eigenvector, except for the 0 vector. So this is an eigenvector associated to I. So in other words, to find the general solution, we need to find the real and imaginary parts of e to the it, 2 plus I, 1. Okay, splitting the vector into real and imaginary parts is kind of intuitive, but remember, to do the exponential part, we're going to have to write e to the it as cosine t plus I sine t, and I'm going to split the vector into its real and imaginary parts. So this is 2, 1 plus I, 1, 0. Okay, now I'm just going to split this into its real and imaginary parts. Okay, so cosine t times 2, 1, that's going to give me a real vector. So when I do cosine t times 2, 1, I'll get 2 cosine t cosine t. But notice also when I do I sine t times that vector, since I times I is equal to minus 1, that's also going to give me a real vector. So this will be minus sine t 0. So this is the real part, and then for the imaginary part, cosine t times the imaginary vector over there is going to give me an imaginary vector. So I'll have cosine t 0 plus I sine t times that vector will give me an imaginary vector. So this will be 2 sine t sine t. Okay, so this part in the brackets is the real part, and this part in the brackets is the imaginary part. It's not, so I is not part of the imaginary part. It's the thing that's multiplying by I that is the imaginary part. Okay, so in other words, for this particular problem, the general solution is going to be C1 times the real part, and I'm going to combine that into one vector, so it'll be 2 cosine t minus sine t, and in the bottom it'll just be cosine t plus C2, and I'm going to combine both these vectors into one, so it'll be cosine t plus 2 sine t in the top, and then sine t in the bottom. So that is the general solution to this differential equation. And again, I just want to point out something that can get tricky or confusing. The imaginary part is just the thing that is multiplying by I. It does not include I. Anyway, this is the solution for this problem.